It's now recording. All right, so today we're going on to cosine rule. So remember, sine rule has a couple of limitations to it. When you get a non-right angled triangle where they give you a side length, they have to give you a corresponding angle. That's one of the first minimum starting points. And then to actually use a sine rule, they have to give you a side and then find a corresponding angle. So there's always a side and a corresponding angle. So for example, B, and then they have to give you angle B. And then they'll ask you, find little b, or find little a, or find big A. This is the only time you can use sine rule. But if you have a problem where they're not matching or corresponding, then you can't use sine rule. Cosine rule is another way to get around it. Okay, and I'll show you some of the things to look out for and how do you know when to use a cosine rule. But let's look at the proof for cosine rule. Same thing again. We've got a non-right angled triangle. Label the corners with a capital letter A, B, C. And if we cut it vertically down from point B, we have the point P, and that makes a 90 degrees angle. So you get two right angled triangles there. Yeah? So I start off by guiding you by saying, all right, let's have a look at this triangle over here. And let's say this length AP, we don't know. Can I rewrite that another way? Now, remember the opposite angles to the corners, those are called your little a's, opposite to c is little c, and opposite to big B is little b, right? If I ask you to rewrite the length of AP is equal to b minus x. Okay, let's fill that in. So we're going to say b minus whatever this x length is will give me the length of AP, right? We're going to use that later on, not yet, just yet. We're going to use our understanding of right angled triangles so far. We're going to focus on the triangle CBP. So CBP represents this triangle. And we're going to use Pythagoras' theorem because we've got two techniques. You either use trig or Pythag with right angled triangles. In this case, we're not using an angle, and we're using the sides, so hence we're doing Pythag. So Pythag, we say that a squared, which is a hypotenuse, is equal to? Very good. X squared plus h squared. So let's fill that in. So we've got a squared is equal to x squared plus h squared. I want you to rearrange to make h the subject. And when they say h the subject, it means h has to equal to something. But leave it as h squared. You don't have to get rid of the square because it's one of the special things as you're doing the proof. If you rearrange this, h squared should equal to what? Beautiful. A squared minus x squared, for those who weren't sure, minus x squared on both sides, because I don't want the x squared, I just want the h squared. So to get rid of this, I'm going to minus them. So x squared minus x squared cancels out. But then whatever you do to the right, you do to the left. So here I minus x squared on the left as well. X squared minus x squared cancels out, and that's why we know h squared is equal to a squared minus x squared. I'm going to highlight that one because this is key. Okay, so now we got what h squared equals to. So it's whatever the height is, and if we squared it, that's what h squared represents. Then we say, okay, well, let's do the same for the second triangle, because it's that h that is special. Just like the sine rule, same with the cosine rule, we know that both triangles share one thing. They both share the height. So if I now look at this triangle, ABP, then I would say the same thing again. The hypotenuse squared, c squared, must then equal to, and in this case it would be again, h squared plus? What's that again? AP squared, very good. And we know AP is equal to? B minus x. So if you said AP squared, then it's technically B minus x all squared. Does that make sense? So the very first start where we said, let's rewrite AP, you're right to say that it is whatever c squared is equal to h squared plus whatever this length is. We've called this length b minus x. So if you're going to say h squared plus that squared, well then it's like saying b minus x squared right there, because that represents your AP squared. Yep.
Is that because we don't know AP's the value of A to be?
That's right. That's right. And the whole aim, as we're doing this proof, you'll realize what we're trying to do here is we're trying to only utilize the letters that we know for the rule. Kind of like sine rule, we only use little a, big A, little b, little c, big C. What we're trying to do is we're trying to replace all of these letters with only A, B's, and C's, the little ones and the big ones. If you can do that, you've got a rule for yourself. Okay, and that's what I'm showing you right now. Eventually, we're going to remove that H, and we're going to remove that X as well to only have A, B's, and C's. Okay, so here we go. Now that we've got C squared is equal to H squared plus B minus X squared, because we know this is your AP, right? But then we also know what H squared is equal to, because H squared, remember, they both share the same height. Both triangles share the same height. So in this previous question that you had, H squared is equal to A squared minus X squared, that can also be applied to this same H squared. That's why I said you don't have to square root it. You can actually now keep it as the squared, and I can replace that. This H squared is equal to that H squared. Therefore, I can rewrite it and bring this down into that bracket there. Okay, so this new equation that you've got now becomes, and it's a big one, and so I kind of wrote it out, pre-wrote it for you. This is your B minus X squared. I've got that, plus the H squared, which I'm replacing with A squared minus X squared. Can you see that? So I've taken this, replaced it here. That's my second line. That's the first line. Now I know some of you may not have learned quadratics to expand, but you have learnt how to expand double brackets. So B minus X times B minus X means B minus X squared. So how do you do B minus X times B minus X again? Remember, it's B times a B, the FOIL method. So B times B times negative X, and then same thing, negative X times B, negative X times negative X. And this is how I got those three lines there. Okay, so I'm going to break it out for you to see. For those who haven't done expansion of double brackets before, B times B gives you?
B squared.
B squared, very good. So I've done B times the B, great, so that one's done. B times the negative X? Negative BX, very good. And then I do the next one, I take negative X times the B, negative BX again, and then negative X times negative X, positive X squared, very good. Putting them together, B squared is there, can't do anything. X squared is also by itself, but these two share a B and an X. So what's negative BX minus BX? Minus 2BX. Because negative 1 take away 1 gives me how many of these BX? I've got negative 2 of them. That's how I got that line there. Okay, so this line is the result of expanding that bracket. What can I simplify? What can I cross off? Very good. I can cross off X squared minus X squared. And this gives me, I like it to write it in alphabetical order, so I'm just going to go A squared plus the B squared minus 2BX. Now we're almost there. Can you see in our formula at the moment, I've got C, I've got an A, I've got a B. So I've got all the sides of that non-right angled triangle. So remember the non-right angled triangle where it was A, B, C. I now have the use of the little a, I have the use of the little b, and I have the use of little c. The problem is x. But I can rewrite x in terms of a, b's, and c's. Let's look at the triangle again and see if you can figure it out. Can I rewrite it in any other way? Can anyone see it? How you can rewrite this length so that you only have a's, b's, or c's. I don't want any x or h's in there. Anyone see it? So, is it only... What I'm asking is that x right now, in the formula, we've almost got the cosine formula. If I can replace x, I need something equivalent to x from that triangle right there. If you can replace that x with only the letters a, b's, and c's, you've got yourself a formula, and that's where the formula comes from. But can anyone see how they replace that x? What can we do to replace this x? Instead of saying x, can I find this using just a, b's, and c's? Sami. Ooh, Well, that is the rule, but I'm interested in where the cos C comes from. Can someone break it a bit further? As in, like, how do you rewrite x?
A squared minus h squared square root of all of that.
Well, it's true. I just don't want the h. So I don't want any h. I just want a, b's, and c's. In the formula that you're going to come up with for x, I do not want any h's or x's. Can anyone see it?
Do we like root negative 2bx over to c squared and then root c squared to a squared plus b squared and then like.
Well, that is another way. There's a shorter way. I'll give you a hint. I want you to focus on just the right angle triangle. And it's definitely not Pythag, so it has to be trig. We use trig in any way to find x. What can we do?
Can we do like a times cos theta?
Very good. Can we see here, remember, this angle we can use, that's capital C. That corner's a capital C, right? So if I want to find x, remember, in your right angle triangle, if you've got an angle C and you're trying to find x and you've got A as the hypotenuse, which function of the trigonometric ratios can we use? Cosine, because that's your adjacent, that's your opposite. So if I use cosine rule, or not cosine rule, but the cos ratio, cosine of the angle should equal to adjacent divided by hypotenuse. So if I rewrite that, it's cos of big C, because that's the angle, should equal to adjacent, which is x over A. Now rearranging that to find x, what would x equal to? And that's what Olivia said before. If you times both sides by A, A's cancel out, and the formula then becomes A times cos of big C is equal to x. So if I take this knowledge now from the right angle triangle from this component and I replace that x now, we go back to our formula over here and we say, oh, that x can be replaced with A times cos of big C. And that's the formula that Sanvi just read before. She said C squared is equal to A squared plus B squared minus 2AB cos of big C. What's nice about this formula is that you only need the angles of each corner and the corresponding side lengths to actually work out any side length. And that's the special thing. You don't need the vertical height. You don't need to know the portion of the right angle triangles. You can just use A, B's, and C's and the corner angles. So the corner angle, this is corner C, that's corner B, and that's corner C. Oh, sorry, A. That's all you need. So if you wanted to find one of the side lengths, just use the formula. There is a pattern to it. So to get you used to the pattern, I'm going to write the other possibilities. Let's see if you can figure out all three. Okay, so I'm going to do the second one, see if you can figure out the third one. So if I want to work out the length of A squared, then it should be C squared, I'll write in alphabetical order. B squared plus C squared minus 2 times BC cos of angle A. Anyone seeing the pattern? All right, no?
Yeah.
So if I've got A here, so notice here, if that's a C, so side length C becomes use of angle C. But then all the other letters are the missing letters. So you add A's and B's, because I'm missing the A's and B's, and then it becomes A times B. So if I were to find A, then it's the other way around. If I'm finding A, then it's the leftover letters. So it's B squared plus C squared minus B times C, but the angle is capital A. Have a think. What would then the rule be if I asked you to find the side length B? B squared should equal to, who wants to have a go? Andrea.
A squared plus C squared equals 2 AC cos B.
Beautiful. Very good. Okay, so all I'm doing is I'm just using the pattern. Once you know one side, then you can use it for all the other sides. And that's your three formulas, no matter which side, whatever corner you label it as, that's the one formula you can use. The nice thing about the formula also means that you can rearrange everything, pull it onto one side to find angles A, B's, and C's as well. but I've already done it for you, and I've given you the formula just below. That's the formula, and all I did was to find cos of BC, I just moved all this across, so that's why it's, actually I moved this one across and I moved this one over. So there was 2a, I'll show you the steps. This is what I did. I did c squared equals a squared plus b squared minus 2ab cos of big C. All I did was I said, that one, let's move it to the right. And to move it to the right, you do the opposite of minus, so I add both sides. And this one, I move to the left. How do I do that? I minus both sides. So that by doing that, I get 2ab cos of big C is equal to a squared plus b squared minus c squared. Because I minus the c squares on both sides. I added these two on each side. And finally, that's 2 times a times b times cos. So I just divided both sides by 2ab, and that's how I got that formula. Okay, but as you can see, I'm doing a lot of algebra here. I don't know how strong most of your algebra is. It can get really tricky, especially if you're using a lot of parameters. Hence, you can just use the formula. But I like to show you where it sort of comes from, because that shows you the thinking that we do in methods and specialists. That's the kind of maths we generally, as a prerequisite, as you're doing. Yep.
So when it's like cos C, it's sort of like negative C squared. If it's cos B, would it be negative B squared? Yeah.
Oh, yes. Yeah. So, yeah, that's true. So you can also do the same thing for, if you change the letters, if that was a B, so capital B, then obviously then you would have A's and C's, okay, and then that would be a B there. Okay, so very similar to how you would write over here. So you can write all your other threes if you like as well, but you only need the first template to then figure out the rest. Coolies? So, when do you use it? How do you know when to use it? So sine rule was when it's corresponding, angles and side lengths. One of the first things I look for cosine, how do I know? And it's a really key one. It's when they give you 2 side lengths, okay? But it can't be any 2 side lengths. It's 2 side lengths in a non-right angled triangle that also includes an angle between those 2 lengths. What do I mean? Not the 2 right angled the 2 sides of a non-right angled triangle, they can give you whichever side, doesn't matter. It could be A, it could be B, but when they give you an angle, it has to be the angle that connects A and B. This is the angle they must give to me. If they don't give me this angle, you can't use cosine. You then have to use sine rule, and then because if they give you any other angles, it's corresponding. Then you use sine rule. This is the only one that you can't use sine rule. Okay, so when you can't use sine rule, it's cosine rule. You see, because sine rule always relies on the fact that an angle is corresponding to the side, an angle is corresponding to the side. In this case, they did not give you big A, they didn't give you big B. So you can't use sine rule, but the big hint is if you've got 2 sides, and the angle that connects the 2 sides, that's when you use cosine. And that's why it's A, B's, and C's. Yeah, so if you notice the formula, there's always one of each one. So if it's an angle C, then you've got the 2 corresponding sides. Same thing with this one. If you've got angle B, that's the 2 corresponding sides. Okay? All right, team. Let's do an example to tie it in. So if you didn't understand the proof, if the algebra was getting a bit tricky, it's okay. Let's learn how to use it. Okay? So all you need is a formula. Most of the mainstreams, when they learn this, they just learn the formula and then learn how to apply. I'm teaching you the logic as to where it's coming from. Okay? All right, flip over to the next page. Yep. Oh.
I was away on Wednesday.
I'll need to print a few more. I'll print a few more after this and then we go through. All right, team. Here we go. Flip over the page. In the meantime, you can write this example down or wait to copy Raho's notes. Let's do this example. So, can you see the questions asking? Find the third side. So I'm missing this side here. I need that side length. Well, what have they given you? They've given you 2 sides and an angle, but that angle, again, is in between those 2 sides. It has to connect those 2 lines that they've given you. That's when you know it's a cosine rule. Anyone remember the cosine rule? So let's call this A. Let's call that B. Let's call it C. You can call it whatever you want. That means this must be little c, this must be little a, so we're trying to find little b. Okay, so what's the formula again? B squared is equal to, who wants to have a go? Jaden? What's the formula if it's b squared? Beautiful. Okay, so it's the two opposite letters, or the two missing letters that we have, a squared plus c squared. Then you times those two letters together, and it's because of the angle, whatever this b is. Okay, so here we go. Let's put in our formula. So our values, a must then be 4, so it's 4 squared, plus c, which is 1 squared, minus 2 times 1 times 4, cos of the angle, which is 100 degrees. Plug in your calculator, and we should get the answer. You can do it all in one go as well on your calculator. I'm going to take out my calculator and have a go too. Let's do this. What do we have? 4 squared plus 1 squared is 1. Minus 2 times 1 times 4 times cosine. Make sure you're in degrees as well. I got 18.389185. Is that what you roughly got? All right, very good. Correct to 2 decimal places must then be 39. Very good. 39 meters. Oh, sorry, this is b squared. I realized. That means b must be, you have to square root this answer actually. Square rooting the answer. Thank you for reminding me that was b squared. So square rooting that answer, how do I do that on the calculator? So I tick, and then I go square root. Where's the word for answer? Answer. I got 4.288261. Rounding its 2 decimal places should be 4.29 meters, which makes more sense since that's 1/4. 1/4, the other one's longer, so it's 4.29. I'll leave example 2 for you to try with the formula. Let's do just a bit of reasoning. I want you to pick for me. Reasoning question 8, A, B's and C's. Which rules do you use, sine or cosine? Let's look at A.
Cosine.
Cosine, 2 sides, so they gave you 2 sides and an included angle. Okay, so it's an angle in between. Yes, this is cosine. That's cosine rule. What about B? Sine, because they're corresponding sides. Angle and sides are corresponding. That is a sine rule problem. And note that it can't be cosine because you've got 2 sides but not the included angle, or the in-between angle. And lastly, C must be sine rule. Or you could use, you probably have to use, no, because cosine needs 2 sides, but you can actually use, you can find this angle here, because in a triangle that must all add up to 180. You can find out this angle and then use sine rule. But you can't use cosine because they didn't give you 2 sides. They did give you an angle in between them, but they didn't actually give you 2 sides. So it wouldn't be possible to do. They gave you 2 angles, and those 2 angles should allow you to find the 3rd angle to use sine rule. Yeah. So this actually is a sine rule problem with a minor step between. Okay, so minor step between. All right, team. That should. Oh, there's another 3. Maybe I'll leave that for you guys to figure out then. Example 2. Have a go. I'm going to write the answers up.